Hello and welcome to Empowered Learning. This video will be about order of operations, and in particular what we will talk about is how we use order of operations to be able to evaluate expressions. So whenever we employ order of operations, we want to follow the steps that we see below here in order. And so the slide says here, simplify expressions using the order below. If grouping symbols such as parentheses are present, simplify expressions with those first, starting with the innermost set. And then afterwards, if fraction bars are present, simplify the numerator and denominator separately. Okay. Now, what this basically means is that we need to do everything that is in grouping symbols first, then anything that's raised to a power second, and then after that we do all multiplication and division going from left to right, and then we do all addition and subtraction going from left to right. That's pretty much how it works. To help us remember that, we have these acronyms. And so one acronym, depending upon where you live at in the world, is PEMDAS and BODMAS. Okay, they both mean the same thing. It's just that it's used different letters to be able to represent things. So we see that if you're in America or countries that follow the American way of doing things, then we know that parentheses stands for grouping symbols, and then after that we do exponents, and then after that we do multiplication and division together from left to right, and we do addition and subtraction from left to right. If you're doing BODMAS, then what parentheses means is the same thing as brackets. And then of course other things comes after that. So that includes anything that's with an exponent. Over here we notice that we just say exponents, but here we see that whenever we have for instance a square root sign, that's the same thing as, let's say, some value raised to the 1/2. So you really are doing exponents there. It's just described as other things. And then of course there's division, multiplication, addition, and subtraction. So when we use these acronyms, we have to make sure that we understand what they're actually trying to guide us to do. And the main confusion comes along whenever we are doing multiplication, division, and addition and subtraction. Please understand that when we do multiplication and division, some people think since it's written like this, we have to do all multiplication first and then you have to do division. That is not necessarily true. Here, if we understand that division, and I'm just going to write A divided by B here, is a convenient way of doing multiplication of a number times the reciprocal of the other, then you realize that multiplication and division really are the same thing. It's just division is just special multiplication. So that is why when we employ order of operations, whenever we have multiplication or division, we do it from left to right. Because if we do it from left to right, we imply this understanding of what division is in terms of multiplication, and we don't mess things up. All right, so let's go ahead and move on to some examples. So our first example here, we see that we have 6 plus 9 divided by 3, and then all that is divided by 3 squared. So of course, the first thing we see is that we have 3 squared, which is 9 in the denominator. And then afterwards, the next thing that you see that we have is division. So we've done exponents here. And then after that, only thing we have left is addition, division here, and division here. And of course, the division that is here is the very last thing that we will do. Because what is implied here is that you have a grouping symbol here for everything in the numerator, and of course 1 over here for the denominator. So we're trying to work everything here, and then divide last. So within this implied grouping symbol, we know that division comes before addition, so that's why we do that first. Okay, and then after that we do the addition in the numerator, and that's how we get 9. And then of course the last thing is 9 divided by 9, and that answer ends up being 1. Moving to our next example, we see that here we have to look in between whether we need to do division first, addition first, or exponent first. And according to our acronym for order of operation here, PEMDAS, or BODMAS, depending upon which one you use, we see that we need to do the exponents first, or the other things first. And so that's why when we come here, we could do the 25 here. So the way that they have it done is they're actually doing the division first. And the reason for that is the following. So if I write this out, we do know that 5 squared is the same thing as 25, or 5 times 5. So when I write this here, it's actually going to look like this. And so if you look at it in that light, you can choose to either do division or multiplication first. It really doesn't matter. And so if we use it as going from left to right, then you see how we would want to do 6 divided by 3 first. Okay. Now, you can still do the 5 squared first and say that it's 25, and you'll still get the same thing. So, of course, working it the way that you see here, we would do the division first, and then we do the exponent, and then we add together. If we would have taken the other way of doing it, then we would have said 25 is here. And then after that, we would have said 6 divided by 3 is 2. And you see, we still would have got 27 as an answer. All right, for the next one, we see that this one has a bunch of grouping symbols in it. And so the innermost expression here is this 2 times 3 plus 1. And so within here, we see that 2 times 3 is 6. And that 6 plus 1 is 7. So that's why you see the 7 there on the inside. And then from there, we know that 5 times 7 is 35. And then from here, this is not written, but the next step would be 1 plus 2 times, and we know that 35 minus 10 is going to be 25. And then, of course, from here, 2 times 25 is 50. And then after that, we just add 1 to that, and we get 51. And so in each of these stages here, we know that since and I'm starting right here, we know that we were on the inside. We had to decide whether we're going to do multiplication or subtraction first. And of course, multiplication wins out. Then of course, there's only subtraction left to do inside of these brackets. So we do that and we get 25. Now at this point, we see that we have addition and we have implied multiplication right here. And of course, we need to do multiplication first. And then after that, then we do addition, and that's how we end up with 51 as an answer. So now let's do some examples. So we start off with this first one, and we see that we have exponents and multiplication. We can do exponents first, and we know that 3 squared is just 3 times 3, which is 9. And of course, 5 times 9 is 45. For the next example, we see that we have multiplication and subtraction to deal with, and we want to do the multiplication first. And so for this one, since we're multiplying these two fractions, we could actually try to reduce before we multiply, and we know that 2 and 4 have a common factor of 2. So that means 2 can go into 2 once, 2 can go into 4 2 times. And so then from there, what's left is just 1 times 1, which is 1, divided by 2 times 3, which is 6. And then we just say subtract 1/6. And of course, 1/6 minus itself is 0. For the next example, we have subtraction, multiplication, and exponents to deal with. So what we want to do is do the exponents first, and so 2 raised to the 5th power is like multiplying 2 times itself 5 times, and that ends up giving you 32. Then from there, we're going to do the multiplication because that's the next highest thing on the order of operations. And so 2 times 2 is 4. And then after that, now we just have subtraction and addition. And of course, as long as we have a string of addition or subtraction, we can do it from left to right. And so that would be 6 minus 4, which is 2, plus 32, and that will be 34. This same rule here, as whenever we just have a string of addition and subtraction, we can do it from left to right. The same thing applies whenever we have multiplication and division. We can do a string of multiplication and division from left to right. All right, so we see example D is already worked out here, so I'll give you a few seconds to look at that before we move on to the next example. And now we're going to move on to these next examples here. So now we work this problem, and we need to do the innermost grouping symbol first, which is the 6 minus 4, which is 2. So we write everything else down, put the 2. And so now after that, within the innermost grouping symbol, we have multiplication now. That ranks the highest. So we do 3 times 2, which is 6. And then from there, inside the grouping symbols, we have just addition. So 4 plus 6 is 10. And then here we have implied multiplication here. And so 3 times 10 is going to give us 30. For our next example, we see that this is 19 minus 3 times 5 all over negative 6 plus 4. And so we see here it is implied that we have grouping symbols on each of these. So we're going to work all the numerator, all the denominator, and then divide. So we start off by knowing that 3 times 5 is 15. And of course from here, we know that we can do 19 minus 15, which is 4, negative 6 plus 4, which is a negative 2. And then of course, 4 divided by negative 2 is a negative 2. In example G, notice that we have these bars here, and this means absolute value. So here we are saying a negative sign and then absolute value of 4 plus 3 all over 8 plus 2 times 5. Okay, and then the absolute value of 4 is just 4 itself. So all of this just ends up being 4. And so since we have that negative there, that means negative 4 plus 3. And then we write down everything else. Okay. So from this point in the numerator, we just do negative 4 plus 3, which is a negative 1. In the denominator, we know that we need to do multiplication before addition. So 2 times 5 is 10. And then of course, from this point in the denominator, all we have is addition left to do. So our final answer is negative 1/18. All right, and so for example H, if we do this one, we see that the first thing that we need to do is what's inside of here, and 8 minus 5 is 3. And then in the denominator, we see that the first thing that we need to do is handle the exponent. Now notice that when we talk about negative 4 squared that looks like this, that is not the same as negative 4 quantity squared like that. So here we're literally translating this to be like another grouping symbol here, so that we do 4 squared, which is 16, and we append the negative on the end. So then from there, of course, in the numerator, we say 6 times 3 is 18. In the denominator, we know that we have subtract a negative number, so that's the same as addition. And then, of course, 3 plus 18 is 21, and negative 16 plus 2 is a negative 14. And then from here, we can just reduce. We know that 21 and 14 both have a common factor of 7. And so here I'm going to actually erase that and just put the negative out here. So we have a common factor of 7, so that reduces to 1. And all we have left is 3 over 2, because 1 times 3 is 3, 1 times 2 is 2. And then, of course, for example I, you have that example. And so I'll give you a second to look at that before we conclude this video. Thank you so much, and take care.